Part of the research for permaculture design involves looking at the site capability. Capable of what, you rightly ask? Well, the primary goal of a permaculture site is to create a healthy lifestyle. We try to meet our needs through sustainable production, and this builds social and physical resilience. But the truth is, not until everyone has a healthy life will the world have peace, clean air, and climate rest. We ask, is the site capable of meeting our needs sustainably? Can it provide food and medicinal herbs? Can it be comfortable and give us the energy to create a comfortable temperature? Is there clean air and water? And how can it meet our social needs? If you are training to become a farmer, so you want to be able to grow food to sell, then the agriculture departments in most countries around the world talk about land capability in a slightly different way. They look at the potential of the land to erode, to be salty, have a low water table, be stony or rocky, and how likely to flood. They look at how deep the soil is because this restricts the types of plants that can be grown. And the standards are very thorough. Now, essentially, the standard says that if the land is flat but not prone to flood and has deep soil, a low water table and not many stones or rock, then you can grow crops. But as the slope gets steeper or the soil gets rockier and the water table is lower, then you need to turn to having animals on pasture or ranging about. Then as the slope gets steeper, they advise that to be used for forestry. And finally, they reserve the steepest points for the wildlife and habitat and for water supply. So in modern agriculture, wildlife is pushed to the harshest soils on the steepest slopes. Too bad if a slow-moving creature needs a drink or a swim on a regular basis. So there are some key differences here between agriculture and permaculture. When the farmer goes to market, she needs everything to be ripe, all at the same time, and all of it of the best quality. So the farmer needs all the site to have equal sunlight, water, and growth. It starts to become more like a factory. The farmer needs that uniformity. This is why fields are big. And the farmer usually uses machinery to harvest. And this is why crops are grown on flats, because machines topple over on slopes. The farmers also need quick and easy transport to the city. This is where a permaculture site can be located on the margins. It can accept the diversity of growth because we don't need all the fruit at once and we don't need truckloads of each crop. To meet our needs sustainably, we need to build on the existing natural assets. And in order to build on them, we need to identify them and learn more about them and how they influence the site. Here are three key factors that determine the site's capability. Firstly, there are indicators to show us what it's capable of at the current time. Secondly, we look at the complexity of the natural system at the beginning before we design. And thirdly, we look at its capacity to conserve what is existing. So looking at indicators, we observe and record the vegetation and forest types and the animals and insects that grow naturally on and near the site. And we learn from local people, especially First Nations people, about what plants and animals indicate the conditions on the site, the minerals, any disturbances that have occurred, and the level of moisture in the soil. Next key factor is to look at the complexity of a system. We compare the existing system with areas that are nearby or in the area, in the region that have a similar aspect. This will tell us about how much complexity we can expect to create on the site. And the third key factor in working out this land capability is conservation. We need to assess how likely is it that the existing habitat can survive. Just because something is there now doesn't mean it will always be. Does the land have the capacity, enough habitat and enough space for the native species to be fed and watered and to allow them to adapt to climate change? When we look at the land capability, we can look in more detail at some key influences. We find what is possible on the landscape, dependent on these factors: latitude and altitude, aspect of the site, the climate, the general climate that is, and then pockets of microclimates. We look at soil types, water, the ability of the land to hold water, and then losses such as wind and erosions. And we look at weeds and unwanted animals, and then pollution and spray, chemical influences. And then finally, we look at the historical use of the site. The equator is closer to the sun than the North and the South poles, and that's why it's warmer there. So as we move further away from the equator, we can expect to get a bit cooler. Contrary to this, a mountain, you would think, is closer to the sun, so why does it get colder as we get up the mountain? The general rule of thumb here is that as we go up, every 300 meters up a hill, it gets 2 degrees Celsius cooler. Now let's have a look at the aspect of a site. How much of the site is facing east or west or north or south? The best aspect faces the mid-morning sun because it allows us to do solar passive housing and it allows for the maximum amount of growth for the plants. At the end of the day, the climate of the region is really important. If you've got a general climate, you can't influence that very much. You can't change the rainfall or the ocean influence or the breezes off the South Pole or the North Pole. You can't change that. So that is going to be a very strong influence on what the land is capable of. What you can change are the microclimates. Microclimates are little pockets of distinct climate on the site. You would notice a rainforest gully is totally different climate, microclimate, to the top of a hill where it's windswept and dry. The next influence on the site is the soil type. Now, some people might think we want to make the same soil type, the type that grows European styles of food all around the world. And I think that's actually detrimental. We're better off to try and eat what grows easily on that soil. Water is life, and the capacity for the land to create life depends on how much water it can retain. A site's capacity is also impacted by destructive forces such as extreme weather or deforestation. Weeds and feral animals can change the soil type, and they often outcompete with the native animals and plants. The ecology of an area becomes less diverse, and the native insects, which are an essential part of the system, lose their habitat. These insects are a vital part of the food web. Some sites have constant pollution. Some major pollution sources can come from kilometers away. And then there's also influences such as salt spray or underneath the soil, which we find in ancient soils such as those in Western Australia. And then of course there's the chemicals from any previous farmers. Chemicals from handling animals, but also from spraying weeds. And finally, we look at the historical uses of a site. They're not always known by the client, so through reading the landscape, we can discover different shapes made by quarrying or mining or logging. We might even notice some water races that were used for gold mining, for instance, or for irrigation channels. And there's variation in fertility that can result from middens in Australia, or archaeological ruins in Europe, or biochar in Latin America. Unusual shapes in the land can tell us about former uses and things hidden below. So you see there are some natural limitations that determine the capability of a site. But there are also ways that our design can increase the capability without destroying native vegetation. The easiest ways to enhance the capability of a site is to create microclimates, optimize the water retention, optimize, not maximize, because you don't want it too wet. By doing this, we have soil improvement and diversity. So you see, we increase our land capability by holding on to what is already unique about the site and adding design elements to boost productivity.